In section 2, we're going to talk about the ambiguous case of law of sines. And that happens when you are given a side-side angle. And in these first few cases, we're going to talk about when the angle is acute. So angle B is acute. The first occurs when side B is not long enough. It's too short. So it actually doesn't form a triangle. So in this case, it would result in 0 possibilities of a triangle. The second case is where, again, you're given side A, side B, and angle B, and B is acute, and where side B is at a perfect length where it would form a 90-degree angle with the other side, and that would result in one exact triangle, because the proportions would have to be so where the 90 degrees would have to be just at that right point. But where the ambiguous case actually comes in is in this case, case 3. What would happen is you would be given a length of B, where B would actually form 2 different triangles, because you'll see the angle of B is the same, the side A is the same, and B is the same, but it's depending on which direction you choose. So you'll see that it forms a triangle here, and it forms a triangle here. So if B is at this certain length where it's not, doesn't generate a 90-degree angle and it's not too short, it actually generates 2 possible triangles. For this to happen, there's a couple things that would need to be in place. Side A would have to be greater than the height of the triangle, and the height would be here. What also would have to happen is that A would be less than B. Now, another thing that could happen is if we're given side-side angle and A is obtuse, and we'll say that this is angle A right here, 2 different situations could occur. The first one is similar to the one that we saw before when it was obtuse, is that A just would be too short and it wouldn't be able to form a triangle at all, so it would result in 0 triangles. Otherwise, the other situation where what it would occur is where side A would be exactly the same, or would form exactly 1 triangle. So there'd be 1 possibility that occurs. And in this case, A would have to be greater than side B. A couple of reminders before we start getting into some of the problems. First of all, any angle theta we know is that sine of theta would have to be between 0 and 1. If sine theta equals 1, then we know that theta has to be 90 degrees. The second reminder is that if we have sine of theta, that is the same as sine of 180 minus theta. Supplementary angles have same sine values. And that goes back to those principles that we've talked about in the unit circle. Let's say that we have 30 degrees right here. We know that's going to have the same value at 150 degrees because the reference angle will be 30 degrees. So that's 180 minus 30. And the last one, you probably remember this from last year, is the smallest angle is opposite the smallest side, the medium angle opposite the medium side, and the largest angle opposite the largest side. So what we're going to do in our first example is we're going to solve a triangle ABC if A equals 17.9 centimeters, C equals 13.2 centimeters, and angle C equals 75 degrees in 30 minutes. One of the first things I'll notice when I'm looking to solve this is I'm given side C and angle C. And that makes it very easy to set up law of sines. So what I'm going to do is I'm going to do side C over the sine of angle C. And I'm given A, so I'm going to do side A over the sine of angle A. What I'm going to do is I'll cross multiply. So I'm going to get 17.9 times sine of 75 degrees, 30 minutes, equals 13.2 times sine of A. And to get sine by itself, or sine A by itself, I'm going to divide by 13.2. And a couple of things to remind you of. Remember, you can actually find this in your calculator by hitting the second button, and then there should be an angle button that you can press on there. Again, what you do is you'd hit that second button, and you can see it's the app key, it says angle, and that will allow you to do degrees and minutes. And you can actually put this all in your calculator all together by doing the arc sign and then putting all of this in together. That will ensure that's the most accurate. And make sure your calculator is in degrees since it's given to us as 75 degrees in 30 minutes. And pause it, go ahead, plug it in. Now what you should actually get is an error. And the reason why that occurs, and I probably should back this up a little bit, is because when you do sine A of this, you actually get 1.31286 ... And if you remember, sine has to be bounded between 0 and 1, which obviously this falls outside of this. So what does this mean? Is that we're at case 1, where there's 0 possibilities because the length of the side was just too short and it doesn't complete a triangle. So there is no such triangle for that problem. The second triangle we're going to solve for is triangle ABC, and we're given angle A equals 61.4 degrees, side A equals 35.5, and side B equals 39.2. Again, this works out nicely because we're given angle A with side A, so I'm going to set up as a law of sines. So I do 35.5 over sine of angle A, which is 61.4, and that equals to 39.2 over sine of B, because B is what was the other one that was given. So I'm going to do what I did in the last one. I am going to cross multiply and set it up. So if I do the calculations that are given on the right, you will get that sine of B is approximately 0.96949 ... Now, we know it's within the range of 0 to 1, so we know it exists. But because it's not exactly 1, we know it can't be in 90 degrees. That would lead us to one triangle. So since this number falls between 0 and 1, that actually leads to two different triangles. And we're going to have to solve both of those triangles since we don't know which one exactly it is. So the first one, what we're going to do is we're going to do arc sine in your calculator. So go ahead and pause the video and find arc sine of 0.96949. And what you're going to get is B is approximately 75 degrees, 75.81 degrees. And back to one of our references earlier on in the video, we know that we can find the other angle by doing 180 minus 75.81. And that's going to give us the other angle, which is 104 and we'll 0.19. And again, if you're kind of wondering why that happens or why we do that for 180, again, it's because sine is positive in the first and second quadrant. So if B is 75.81 degrees, that not only is the angle, but it's also the reference angle. And so sine would also have to exist over here with that same reference angle as 75.81. And to calculate what that full angle is, we do 180 minus the reference and get 104.19. I'm going to go ahead and round that to the nearest tenth since that's the other significant digit. So if the first angle we'll use, so if angle B equals 75.8 degrees, then we can actually calculate what angle C is right away because we know a triangle is 180 degrees. So we'll subtract the 75.8 and we'll also subtract the 61.4, which was given earlier. And that's going to give us angle C, which is 42.8 degrees. So now we have all the angles. And what we're going to do to finish up is that we're going to calculate the missing side, which is side B. So I want to use that proportion again, 35.5 over sine of 61.4. And I want to equal that to find side C. And since I know the angle of C, I can use 42.8 now. So why don't you go ahead, pause this, see if you can solve for side C. You should get 27.5 centimeters. But remember we said that there were two possibilities. So that would be the possibility for the first triangle. The second possibility would be if angle B equals 104.2 degrees. Well, I can go ahead then solve for angle C based on the same way I did above. I do 180, but this time I would subtract 104.2, and then I would subtract the 61.4. That would give us to have angle C equal 14.4 degrees. And then again, I would set up a proportion as I did in the previous step. But this time, sine of C would be sine of 14.4. Again, why don't you pause that to see if you come up with the same C as I do. And I get 10.1 centimeters. In our last problem, we're going to solve for ABC again, triangle ABC, but this time B equals 68.7 degrees, B equals 25.4 inches, and the A equals 19.6. Why don't you go ahead and pause the video and see if you can come up with angle A and then pause it after, or restart it after you get angle A. So what I did is I set up a law of sines and I calculated for angle A, and once I put it in my calculator, I got sine A equals 0.7189, and then the actual angle was 46 degrees. Now, some of you might have already started doing this, doing 180 minus 46 degrees, and that gives you 134 degrees, giving you that second angles since this falls between 0 and 1. Now, I have to look at this for a second. So this is angle A, or this could be angle A. If I reference back to the original problem, side B is greater than side A. Therefore, angle B should be greater than angle A based on one of our references earlier that the biggest angle should go with the biggest side, smallest angle, smallest side. So therefore, we know that B is 68.7 degrees. So B should be greater than A. If I look at this first one, B is greater than A here, so that works out okay. But B is not bigger than 134, therefore 134 cannot be a possibility. So I don't need to solve two triangles, I just need to solve the one for this problem. So now to finish solving, I'm going to find angle C, and I'm going to do 180 minus 46 minus 68.7. That's going to give us 65.3 degrees for angle C. And finally, I'll finish up with the law of sines by doing 25.4 over sine of 68.7. That's going to equal I need to find side C. So it's going to be side C over sine of 65.3. Once you're finished calculating that, that's going to give you side C to equal 24.8 inches. I do want to go back and reference number 2 real quick before the video ends on why we ended up with 2 triangles in problem number 2 and only 1 triangle in problem number 3. In problem number 2, we have A and we have B, and A is smaller than B. Therefore, angle A has to be smaller than angle B. So when we go to generate the two angles, we came up with angle B here, 75.81, and 104.19. But if you look at what angle A is, 61.4, both of these angles are larger, so that's why there were still 2 possibilities.